Thank you everyone for joining. I know it is an absolute scorcher of a day and you could be in a pub garden right now having a few beers, but you're here listening to me about AI native development. So I give you my thanks and I also question your life choices, but here we are. So we're going to be talking about how we navigate this new thing that we're calling AI native development, what it is. We'll talk through a number of things, including what we are now calling code-centric development, which before AI, I guess we just called coding and development, and how we use AI to empower ourselves and get further with code-centric. We're going to also talk a little bit about some of the lessons that we've learned at Tessl, because at Tessl we're building some cool AI native development platform, and we do a lot of prompting. We try and get a lot of generation and testing coming out of a number of models. So our AI engineering team have given us a bunch of learnings that we want to make sure we share with as many people as possible as well. Then we flip it around really, and we talk about, well, what is spec-centric? How do we build software via a spec as our source of truth? What does that look like? How does it change the way we develop software? And then finally, look at why AI native. What else does it bring us that a code-centric world doesn't provide us with? Cool. My name's Simon Maple. I'm one of the founding dev roles at Tessl. And Tessl's a just over 1-year-old company right now. Anyone heard of Snyk? Snyk? Does anyone know what it means? No, what it means though, sneak. So now you know. It's the biggest secret, which is an ironic way of so now you know, but no one knows. So the founder of Snyk, Guy Pajani, moved over to Tessl, brought a number of people actually from ex-Sneakers, from the ex-Snyk founding team. I was one of the lucky ones who kind of joined early with a number of other people who are in this room. And yeah, AI native development is what we're building. Okay, let's start off with code-centric. And we'll talk about how we build code. We can still build applications in a code-centric way with AI. I built this application actually for a workshop, a conference called Open UK. Anyone Open UK here this year? Just Sammy, who was organizing it, so that doesn't count. Okay, let's jump over to an app that I created. As I mentioned, I created this using Bolt. And the idea is, it's just an application that takes in some prompts, generates code from the prompts. It can iterate through that code based on the prompts I provide it with. And then every single time code is generated, it runs a set of tests against it. So I can use my prompts to make my code cater for a greater number of scenarios, eliminate bugs, add some more bugs, et cetera, et cetera. In this case, the system prompt here just says, the usual, you're a JavaScript coder, blah, blah, blah. And the goal of this is to create a pluralizer function. So generate a function called pluralizer that takes an English word and pluralizes it. So as my chat, I might say, create a function that takes a word and you can see how bad my typing is now. And pluralizes. Is the text okay for the back? Yeah, all good. And pluralizes that word. And yes, I am writing in US English today because I don't want to confuse it with the function name. Okay, so it's created that. That looks short but reasonable. 18 of my tests have passed. I can see at this stage what is passing, what is failing. It looks like right now there's a number of exception words and other knife to knives, wolf to wolves, and other patterns that it's missed. When we prompt, one thing that's really, really important, there are certain times when we want an exception word whereby there is no rule here. This is the word I want to get if you get this word. When we write sometimes tests and generate code from tests, or when we give it specific examples, very often it will say, oh, I'll write code that fixes that exact example. Whereas when we prompt, we actually want to get it to do something more generic. We want to say, I might say something, I could just say something very generic here, like take into account the F and FE endings rule. And apply this and apply these cases in my function. And then what it will do is it will, let's see what it's done. Okay, so it's changed F to VES and FE to VES. And hopefully, can anyone remember what my number was before? 18, so it's added 5 successful tests and so forth. Oh, there we go, look, some of those are fixed. I might also say add exception cases. Exception cases and words that do not change. Who isn't a native English speaker here? Oh, I really feel for you, because when you write this, you realize how bastardized the English language is and how hard it is to... okay, so we test that. Oh, look what it's done now. It's added some wonderful English for me. So I've updated the code. Thank you very much. Okay, I just hit update code, and now 27 of my tests have passed, and you can see now I'm adding greater and greater cases. However, what's the source of truth here? Let's see. Everything that I've added in this chat is very disposable. Okay, every single time I put a prompt in, it takes me from it takes me from one place to another place. The version of code before that prompt was written and to the version of code afterwards. If I apply that prompt, if I use that prompt at any other time, it doesn't make sense, because it only applies to the state that existed on that first version. So everything here is disposable. It's throwaway. Okay, I can't get back to this stage unless I have that initial state followed by these prompts, and the AI, in a deterministic way, which we know it doesn't work like that, does the same thing every single time. So this is all throwaway, and even if I wanted to reuse it, I can't. The source of truth is the code. Okay, so this is how AI is getting me to that place faster, where this is still code-centric. I check in the code, I maintain the code, I manage the code. AI is just helping me write that code. Okay, who's used Copilot? Who hasn't used Copilot? Really? That surprises me. I was going to not demo Copilot, and I'm still not going to, because that's your fault, right? Everyone should have used Copilot by now. Copilot, okay, was one of the original, I'm not going to say the original, it's by far not the original, but probably the original mainstream coding assistant that you can just tab prompts in your browser as you type away. But it was quite simple. It very often just did one line or a few lines, then went on to a function, and now it actually does more and more things. One of the kind of bigger players, let's go to this one. One of the bigger players is Cursor, of course. Who's used Cursor? That's a far more interesting tool. Cursor does obviously things like multi-file changes, which GitHub now does as well. But it has this kind of like this chat that allows me to interact with it, ask questions, do much more complex changes through this more agentic style. This is an example. I think this is for those who watch the podcast, this was actually the example code that a guy called Joe. We just call him Joe. Joe. He's just Joe to everyone. He's like. Say again? Holcroft. Yeah, he's like Kylie or Madonna. It's just one name. We know him as. So Joe wrote this using Bolt. Yeah, not Bolt 44. Bolt.new. I used base 44, and I can just import this and go ahead and make some changes. This is actually like a SimCity style thing. I might make a change. Maybe I'll just say make sure there are buildings of many different costs and levels. Okay, when I make that suggestion, it goes away, it thinks about a bunch of stuff, it works out what it needs to change, it applies those changes, it does it to multiple files, and as Matt was saying, we just blindly ignore what it says, hit accept all, and then vibe code through our test. I think that's what I learned from you, and then just go push to production, right? Yeah, perfect. That's what I learned. So, yeah, yeah, I knew you'd love that, Richard. So yeah, it's made some changes to index, it's made changes to game reducers, etc., etc. I just hit accept all, push, all good. Now, there's something else that I'm going to show you, which is bolt.new. This is kind of like vibe coding, where it's very code-centric. It shows you the changes. You maybe run some tests afterwards. You're very much in your IDE, and this is, of course, VS Code, or a fork of VS Code. However, the next step beyond that is vibe coding, where we don't actually look at the code. We're not focused on the code, but it's vibe coding where we're almost like click testing. So this is much more of a kind of like a bolt.new. So if I were to come back here and go to bolt.new, what I might say here is, who wants to build name a simple app? All right, okay, no. An app, create an app, create an app that interrupts someone's flow with a random noise like a can opening. Perfect. That was like, we needed no words for that, didn't we? We're on the same level here, I can tell. So what Bolt will do is now, Bolt will go ahead and start, it thinks, it loves thinking, using all my tokens up, thinking. It'll probably tell me what it's going to do using more tokens. There it goes. And it is going to create this structure of an application and then start building that out. I could click on the code and start looking through all the changes. One of the core things about the way Bolt builds is, as you can see, it's writing me a whole ton of code. I don't think still today, maybe people who use this more than me can keep me up to date, keep me honest with this. I don't think it will really share with me too much of a diff here. Whereas cursor kind of like says, these are your changes, do you want to accept them? This may only change one line or a couple of lines, but it will rewrite the entire file. It makes it quite hard to almost like see what's changing. In this case, it's created some initial files, installed some dependencies using npm install. I'm going to have to actually turn my volume. Oh no. Right, I'll mute that. It's updating this application. A couple of interesting points about Bolt.new. It's very opinionated about the things it uses. So things like Supabase, as a great example. If you wanted to use some persistent storage, it will kind of like, it has a wonderful integration with Supabase, where not only can I just use it with a few clicks, but it will also make changes to the necessary changes to permissions, table sizes, and things like that. It also has an awesome integration with Netlify. Netlify, look at this, amazing. It will create me, I can just one-click publish up to Netlify. Even if I don't have an account already, it will do it for free. And then as I want to take it on, I can push it over to my account and so forth. So here's a flow interrupter. Amazing, look at that. It tells me how many interruptions, and excellent. Right, so I'm gonna hit start.
You might need to now echo it.
Okay. Come on. Right, I'll turn that off. Okay, we get the idea. If I wanted to make changes, I would literally make changes as text here. It would update this system. Have I looked at the code? Have I seen the code change? No, I go forward and click that. I might say, I want the defaults to change to blah and blah. I want these additional controls. I want different sounds that I can choose. Would I go into am I asking it to create tests? Has it got any tests? Absolutely not. Right, this is a completely different, it's the same vibe coding, but it's a completely different level. I'm looking at it from the UI, not the code as much. Cool.
It keeps interrupting you, by the way.
It does. Thank you for that interruption, by the way, Beth. I appreciate it. Okay, cool. One last thing that I'm gonna talk about. Nothing in here. We mentioned Claude Code. Anyone use Claude Code? Super cool. If you haven't used it, have a play. It's amazing. Okay, I'm in an empty directory here. I'm going to write Claude. It says welcome to Claude Code. Create a new app or clone a repository and do these other things. I'm just going to say let's create an app that takes let's create a script create a script with a dice roll function that takes dice roll notation. For example, let's say 2d6. What this means is 2 dice with 6 sides. So if I wanted to total this, it might be 12, between 12 and 2. And return me the total. So the first thing you'll notice, it's entirely terminal based. It will create me some stuff. It's got this awesome to-do stuff. awesome to-do list where it can kind of like go through all the tasks it's going to do. It checks them off, things like that. It's gambling, which is pretty cool. So it's obviously gone to some site to gamble. Do you want to create dice roll.py? Damn, it's doing it in Python. Okay. So that looks good. It does some calculating. Look at the tokens flying up there. Create dice. Okay, has it done it? It's done it. Let's test the dice roll function. There are no tests created. It's only source created. But if I was to say create some tests, it would do that for me. I run that. Do I want to execute this bash command? Yes. Command not found Python. Oh, I've got Python 3. Yeah. Okay, the dice roll function works correctly. So it's run several tests. Well, it's run it several times with an expectation, and it seems to work out okay. Interesting. 3d8 plus 2. I've never seen that before. Oh, okay. It's just done some math on the end. Weird. Okay. Cool. So this is kind of like Claude Code. Very, very interesting in the terms of being able to use this in a workflow as well, because it's just CLI. I love the flow of this, where you can actually then invoke this from other places. But yeah, pretty cool. And of course, now on my local machine, I've got that. I can cat it, and you can see the code it's produced. But we don't want to see code now, do we? No, we just want to see it works. Okay, cool. The problem with all of this, well, not problem, but an interesting thing that we need to remember about this is everything here is code-centric. Everything I've done gets me to the position of code quicker. And it actually takes me away from potentially some of the things that would guard me from problems in code, because I'm going to code faster, ignoring a lot of the usual steps, the good steps that Matt was kind of like talking about there. Before we jump on to more specs, I want to talk a little bit about prompts and the way that I've been writing prompts here, which is kind of like you give the minimum possible. On the podcast, Des Traynor, one of the co-founders of Intercom, said this beautiful line, which I always forget and misquote, but it's something along the lines of the ability to short prompt, meaning the ability for us to be able to write something short and actually get the LLM to do something for us, robs us of that ability to actually give an LLM detailed information about what we actually want. So because I can write something short and get away with it, I do it. And I'm actually not putting the information that I need very often. So when we think about prompting, there's a number of times that prompting won't actually help. For example, maybe, I don't know, context is too large. Maybe we need to give it too many rounds of iteration, for example. Sometimes context windows are very, very important. Now, context windows for models are absolutely huge these days. And if you give that much information, the LLM stands virtually no chance of understanding which bit of information it should use to actually provide you with that. In fact, you don't even need to go close to the context sizes. You will notice that if you probably go through like a quarter or something like that, or a third, you'll probably see your value actually degrading from that. So the attention decay is important. Sub-level token tasks, or yes, sub-token level tasks rather. Who's tried to do a code diff with an LLM? How successful was it? Not successful at all, because tokens actually span more than one character, right? So it's very, very hard for it to identify what the changes are. Word manipulations. Here are 3 anagrams. None of them are anagrams. In fact, these 2 are blatantly not anagrams. This is the same text twice, which is, I mean, I suppose an anagram tester would say it's an anagram, but it's not an anagram, right? It's not great with things like words. It's not great with things like math. We know this, okay? We know there are functions and things that we can use to, it's testing this as a string, for example, right? We know this. No, sorry, it's not. It's taking that as 11 rather than 9. A couple of other things, how LLMs read your prompt. Did you know an LLM starts processing its response before it actually finishes the prompt that you've asked it? Finishes the response before you've finished reading that prompt. What that means is the most important things that you write are at the very start. Because if you've left something really important till the end and it's actually already constructing that response, you're potentially missing certain things. Let me give you an example. There's 2 solutions to this, actually, before I give you that example. 2 solutions. One is, well, let's do this thing called prompt sandwiching, whereby this is very much like talking to a child, right? If I was to ask my 9-year-old not to play with a football indoors, I'll say something like, right, don't play with that football if he picks it up. Oh, and can you make this thingy over here? And stop playing with that football, because it's important at the start. It's important to remind them at the end. And so this is actually a very common way of asking that LLM to do something either side. Now, when we structure prompts, a real interesting way that we have done this a couple of times within Tessl is we're not talking about strict XML, or I think we did that in the early stages, but we use XML tags in our prompts, so that this structure whereby we say these are the provided materials, this is the specification, here's some template code, you can refer to other pieces within the specification very, very easily. And the LLM loves that structure. This is a far better way of getting an accurate response than if you just put it as one massive code block. So structured prompts work as well. Now, this is something that Macy Baker, for those of you who I guess watch the podcast a little bit and follow our blog, talked about, which is called task framing. And if we think back to that fact that an LLM starts responding, starts creating that result before it finishes working out your prompt, when we think about constraints, this constraint here, do not use any external dependencies, for a prompt that is asking for something that, a software component whereby what it absolutely wants to do is use software components. For example, what is this? JavaScript package. It's a markdown specification. Yeah, okay, it's not really saying what it is. But typically, there are a ton of examples out that this LLM has trained on, which uses third-party dependencies. If I'm telling it not to use third-party dependencies at the end, by the time it's already started reading this and constructing its answer, it's already thinking about and using data that it can that constructs that with third-party dependencies. When we run this, we pretty much always got a result that used third-party dependencies. So what could we do? Well, because we know the very top is one of the most important parts of our prompt, we could move this to the top. But what task framing is about asking the LLM to do something, framing that task in a way whereby your constraint becomes the way that you speak, the way that you ask for something. So do not use any external dependencies turns into a self-contained JavaScript package. It's not a constraint, it's the description of the style of package that I want to use. It's self-contained. It's not going to use third-party dependencies. That's task framing. A few other tips before we move on. The more detail you provide it with, the more constrained you're expecting it to find results in a smaller set of information. I would say only provide it with the constraints, with the things that you care about. LLMs are great at filling in the gaps. Only say the things that you super care about, and then maybe over iterations and other things, you're able to kind of like make smaller changes. There's a couple of other things there, but the model.say is really, really interesting. When we were priming the models with context, we noticed that when we tried to do it all in one go, it would give us a whole load of bullshit about, oh, that's a very interesting problem. Let me think about this and da da da. But actually, we want just the answer. For example, when I asked for that code example, it said, oh, here I've updated that code, blah blah blah. What model.say is, this is actually very similar to my kids, because you say this thing and then you just throw away the response. All right, that's what my kids do. They tell me something and then I say something back and they just ignore me completely. The fact why this is important is because we're adding context into this discussion with an LLM. Then as soon as we want something, we ask a very straightforward question and capture the response, and we get just that response. Okay, so it's really a really important way of getting just the response piece that we need, priming the LLM with context previously. Okay, whoa. So some prompt takeaways. Modularization is really important as well. Make sure the scope of what you're asking for is small, and then kind of like combine, exactly like we build software today. Software components that reuse each other. Let's make sure that's modularized, and exactly the same with prompts as well. And yeah, I think one of the key things here is as well, don't use LLMs for everything. Recognize what you can use LLMs for, where you should use them, and have a balance between LLM usage within your app as well as outside. So we'll take a little step away from code centricity now, and we'll talk about what spec centricity is. Now, I want to take you, first of all, back to this kind of like prompt scenario where I prompt, generate some code, run some tests against it. This time, we're going to do it in a spec way. And in a spec way, there's a couple of things here. I have a specification. The code is generated from that specification, but that doesn't mean I can't use prompts, because I might use the specification assistant to help me generate that specification. So this is still disposable, because I'm throwing away the actions I make between the versions of my spec, but the specification itself is the thing that should last. The specification itself is my source of truth. Code that then gets generated from it is just generated code. It's a code from the moment in time that this specification existed. So I might have a template, and that template might say, I want some functionality. What are the things I care about this function doing? I might have an API definition, take a word in, respond with a word. I might have a number of test cases as well as part of my specification. Then, when you know all of this, generate the code from there. I might say, create a specification that creates a pluralize function, which takes a word as input and pluralizes it. Okay, it makes some changes. It gives me a functionality, some API definitions, some test cases. Now, interestingly, it's given me some test cases, which it might, if I just click generate from spec here, we'll see what it does. It might, yeah. I know it's actually done pretty well. Unchanged. Wow, that is surprising how good that is. First time around, 51% of an absolutely abysmal language. Not bad. And I don't mean JavaScript, I mean English. Although, yeah. Now when I make changes, whether through the prompt or through this retains my current state. I can now generate whatever I want from this. Maybe I want a Java application that does this. It doesn't change my specification, I don't think. Maybe certain words like function and things like that. But if I did this in a language agnostic open API way or something like that, I could do that across different languages and so forth. Maybe even different spoken languages as well for pluralization and things like that. Okay, let's jump into why or how specifications change the way we're going to work. So LLMs, yeah, they're magical. If I say create a simple page, which is a to-do app, it provides me with this simple page of a to-do app. I type a to-do in, I hit add, does it work? Of course it doesn't. So I say clicking add does nothing. It implements it. Clicking add does something, wonderful. But of course, why change the damn button color? I didn't ask you to change the button color, but it does it. And is it wrong? No, it's not wrong, because I haven't asked for it not to be blue, or I haven't asked for it to be blue specifically. Where is this decision captured? Today, well, code couples the what and the how. It has the intent and it has the implementation. So if I was to look at someone else's code, did they do that because that's just how they chose to do it? Did they do that because that's design? It's part of a requirement? I don't know. I'm going to change it and I'm going to break it anyway. That's why I'm a developer advocate these days, not a developer. But code couples the intent, the what and the implementation, the how. That's core to what we're going to be talking about. So software development is code-centric. We start off with a requirements document, a wonderful PRD somewhere. We generate some code from that. And of course, the requirements document's perfect and has every edge case written by someone who understands exactly how to develop software and build software. So we create this code, first time around, boom, YOLO. We package that code, we create some documentation, we probably write some tests. When we think about what's disposable, what's long-lived, the disposable piece is the requirements. Yes, that will go out of date so quickly. The code becomes the long-lived thing and the source of truth. And typically, these are paired pretty well because they'll typically run in some CI/CD. The docs is descriptive of some version of my code, and then this will typically be built every time. Of course, we release, an enhancement comes in. No problem, I'll fix the code. No one touches the requirements doc, of course. This has come in through some issue or some other feature. We update the code. Bug fix, yep, I'll fix that, no problem. Edge case, oh shit, yeah, you can have specific cases. Oh, Latin plurals, I see. Okay, yeah, I'll add that. Ecosystem changes, oh yeah, Spring's got another update, and oh crap, I have to change these interfaces now. Yeah, our code base suddenly looks pretty awful. And if you was to look through this now and tell me, is this design or is this an implementation choice? Is this intent or just a how, an implementation? People would struggle to answer that. And if you look back at the disposable stuff, the actual useful intent, it's very hard to work out which change came in where, and because none of this is version controlled. Well, a lot of this isn't version controlled compared to the code. So, oh yeah, docs, I forgot. See, I forget now to talk about docs, let alone forgetting to update the docs. Docs falls out of place, tests fall out of place. Either we lack tests or we stop running tests because they break. This is just the problem that we have today. Has anyone not experienced this? Just you, just you. Oh, I thought you were going to open another can then, I really did. Okay, when we go into the maintenance cycle now, the maintenance cycle is super painful, okay? Because this turns into legacy code and everyone then gets pretty afraid as to what to touch, what, whether something is intentional, whether something's not intentional. If they change something, what if that breaks something else? It just becomes a bit of a spaghetti. What does an AI dev tool do? It accelerates this. It accelerates this because these will come in at the same speed. Or if we're using AI tools to find these issues as well, it'll come in faster. We'll get from this stage to this stage faster, okay? Because of course, AI tooling creates code for us very quickly. And of course, we don't look at code reviews and things like that, do we, Richard? We just accept all, push it, and if it's broken, Richard, someone will send the bug fix, right? So this is absolutely not the true potential of AI, okay? The true potential of AI, we believe, is spec-centric. And what spec-centric means is the change we are making is the requirements become long-lived, the code becomes generated. That's huge. Whenever we think about making these types of things, they're made in the requirements doc, and this only contains intent. It only contains intent. It doesn't contain the how. I don't care how it's built, as long as it passes these tests, because these tests validate my intent. The core thing is a specification is the combination of your requirements, your intent, and your tests. I've chatted to a number of people at a number of conferences who actually have a good argument, which is, well, actually, your tests are your intent because your tests are stating how something should run. It's the TDD method, it's TDD methodology, right? I write my tests, and the code is just something that you write to pass those tests. And when your tests are satisfied, your intent is satisfied. The code isn't then just generated on the requirements, it's generated on the entire spec, okay? Docs no longer need to be this descriptive thing. Docs could be something that is also generated, built from the specification, built from the implementation potentially as well. So what are we saying here? Well, we're saying LLMs decouple the what from the how, the intent from the implementation. The what we can very easily describe. We can describe it through language. We can describe it through audio. We can describe it through video. Maybe we can one day do some descriptive dance to build an application maybe. The LLM will take that what and it will build that. Now, the interesting thing is as well, we don't need to be fully expressive in our spec, in our intent, because actually the LLM can actually fill in the gaps. And when we think about things like BDD, which was a wonderful thing back in the day, one of the big things that it needed to be was fully descriptive of every single case. But actually the LLMs, if you say create a tic-tac-toe game, it knows what tic-tac-toe is. It knows how these types of games are built in the past. It knows what a UI looks like for this kind of thing. It fills in the gaps. So LLMs not just make specs practical, but if you think back at things that we really liked, like BDD, but just really found it hard to implement, it makes things like that practical as well. So this is what we call AI native development, this spec-first, spec-driven development where code is generated, tests are part of that specification and part of your intent, and docs and other things like that align. Also, when you make changes, let's make a feature change, let's make a bug change, it either changes in your actual implementation, or if it changes in your, if it needs a change in your spec, as you write your spec, it doesn't just adapt the code per se, it can just regenerate massive chunks of your code as is needed. So let's do a demo of AI native development. Who's heard of a man called Dion Almaer? A few people. Yeah, folklore says he used to be the head of DevRel at Google and where else? Shopify and Augment Code. Who's heard of Augment Code? That's a pretty cool agentic style coding assistant. He kind of built this. He vibe coded. I don't know what he used. Maybe Bolt.new or something like that. But he wanted to say, how far can we take spec-driven development? And he used this over 2 weeks. He built a POC. And this POC, let me take you to Cursor. This POC is called Specify. And Specify or specify?
With two C's, I think.
Specify.
How much do you want to bet that's 2 C's?
The first
Come
version
on.
was two C's.
The first version was 2
I'm
C's.
dyslexic.
Okay, Specify without 2 C's, as you can see. It gives me a number of options. I can create, it pushes me from state to state. I can start with a brief. That'll take me to a spec. I can generate code. I can generate tests. I can run those tests. I can even run those results in a REPL. So for example, if I take something like this brief, very short brief. In fact, let me take the CLI brief and we'll use the CLI brief. The CLI should take a string. Oh, we recognize this. A dice notation format, D46, return the result of the rolling, the specified number and type of dice. If no arguments are provided, default to 1d6, and the echo should be what is being rolled and the result. So rolling 1d6 would provide 5. So let's come down and we'll say, let's say specify brief to, let's do brief to spec, and we'll pass in the brief. This is just using OpenAI's GPT-4o. It's chosen the language JavaScript. I think I'm not sure if that's by default. I think I can change that. And it's written me a specification. In my specification, we get a very similar output where, okay, we've got a specification for a component called dice roller. It's got an API. It's a JavaScript API. It's got a function called dice roll, has a notation. It's got some tests. These are the types of tests that we want to run, and some and some output as well. So it's got some test types and some output. So these are kind of like more validating certain things. So this is my specification. I might want to make changes to the specification. I might want to generate. In this case, yes, let's YOLO it, and let's say specify spec to let's create some tests. Spec to tests, and we'll pass in our spec. Now it's just going to run. It's going to create me some tests, and I can then, well, I'll create the implementation as well, and then I'll execute those tests against it. We can take a quick look at the tests that are generated. And the nice thing is, I don't mind this. One of the things is, you know, as we ask it to do greater things, especially like agents, and I'll show you a blog actually that Patrick Dubois wrote recently, these can take a little while, and that's okay because it's doing a ton more than me doing one-liners. When I do a one-liner, and I was talking to the folks at, I think it was Cody or maybe Tab9, they were talking about the amount of time it takes them from essentially writing something, for a user writing something to something appearing straight away. And if that is slightly slower than a few hundred milliseconds, the user gets annoyed, okay? However, with this can take 10, 20 seconds. When we look at agentic, you hear about people who kick stuff off overnight, come back the next morning, and that's okay because of the amount of work it's doing. So I've created some tests. In fact, talking about, let's do spec to impl as well. And let's have a look at the tests while that's kicking off. I'm doing the cardinal sin of spec-driven development, which is look at the code. But actually, this is fine because I'm looking at the tests, and the tests are intent. And I'm validating that the tests are actually testing what my intent requests. Had a really interesting comment from a guy, Baruch, when I was in wherever it was, Stockholm. AI Focus, really interesting new conference that just kicked out this year. He said to me, An interesting way of thinking about it is, who's heard of Gherkin and Cucumber, BDD style tools, yeah? He was talking about creating a Gherkin specification whereby I describe the usual given this, then that, blah, 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 and then having Cucumber run to turn that into tests. There's no hallucinations. There's no, getting things wrong, because that is, it's an LLM is nowhere near that. So all I need to do is make sure that I validate the given this, then that, to make sure that the tests that I am writing are going to be correct. In this case, though, we're just YOLOing it with some LLMs. So yeah, a bunch of tests. Has my impl been created? A whole bunch of impl, but we're not going to look at the code. We're just going to say, let's run the tests. So let's say, oops, specify run tests. And it runs 13 passed. One test file, 13 tests, all passed. That's quite unusual, actually. Sometimes it fails. But I would still say, if they pass or fail, let's ship it and specify. Let's go into the REPL. In the REPL, I see an available function called dice roll. I'm going to run dice roll passing 4d6. So 4 dice, 4 rolls of a 6-sided dice, rolls 2, 6, 2, 2, 5, total of 15. Yes. I can do a number of them. So maybe I'll say let's have 2 rolls of a 10-sided dice, and it will do that. 7 and 4, total 11. Yeah. I might say I want to change the spec. How do I change the spec? Well, actually, I'm in Cursor right now, so I'm just going to say, let me grab the spec. Okay, I'm going to add that. I'm going to add that as context. Add that as context, and I'm going to say, change my spec. What should we add? So that it makes a can opening noise every so that so change my spec so that it shows an emoji dice on output. I should say die, shouldn't I? And doesn't show the individual. No, let's still show the individual roles, and shows the individual roles on separate lines. So it's going to change my spec. Now what it's also doing is it's changing my tests in my specification. Okay, so it's changing what it should expect to see. And yeah, that looks pretty good, actually. Let's apply that to my spec. And this time, I'm going to write specify. Let's go spec to code. That's the YOLO. I'm in the REPL, thank you. Specify spec to code, which does import and tests, and spec.md. Now, the important thing here is, because we're running through this again, everything's going to be regenerated. Also, by doing it with a chat, if I have a long specification or if I have multiple specifications, it should be able to update all those cases, which is another really important thing. Because if it's code and we only update one thing, okay, we forgot about these other things. But LLMs can actually really help us here, because they know, particularly in written language as well, they know what to change and where. So this is a far better way of doing that kind of thing. So it's done it again. Let's run some tests. 4 failed, 9 passed. Ship it, specify, REPL. I'm sure it's good enough. Okay, now if I do dice roll and pass in 4d6. Okay, it kind of does it. It's just the terminal's bad at displaying this, but it's giving me new line characters, and it's telling me dice 2, 3, 5, and 1, which is 11. Nailed it. Okay, a core thing here as well is LLMs can take that output of failed tests and actually change the impl as well. And of course, on Specify, what I could do as well is perform a fix. And a fix will take in my spec path, it will take in a number of files, it will understand why tests are failing, update the specification, or if it's a code problem or a test problem, it will learn, okay, here's the problem, I regenerate. Okay, and it regenerates based on the output of those problems. So it identifies, there are a few places now that these errors could exist. But we want to make sure that if it's a bug, the impl changes, not the spec. If it's a problem with our intent, the spec changes, and then the impl changes. But it's core that we recognize where the issues exist. Okay, I did promise one last thing. This is AI native dev. A developer site that does a number of things, blogs, podcasts, conference. Bap here does a whole bunch of writing on it. Sammy here runs the AI Native Dev conference. We're actually, don't tell anyone. Oh, it's not been announced and I'm recorded, aren't I? We're going to be doing an in-person conference in November. And it's really close to London. It's probably about 3,000 miles away from London. So keep a note for November, and we'll be announcing more about that soon. There will be some live stream aspects for that as well. But yeah, feel free to register to subscribe onto this, and we'll give you a ton of news about blogs, about the landscape, about conference, and other stuff. This is a really interesting blog that Patrick Dubois. Who knows Patrick Dubois? Yeah, a bunch of people, of course. He's the father of DevOps. He's the half brother of dev tooling. And he's your conference sister as well, isn't he? Yeah. He's an amazing guy. He's a Belgian dude who's so up to date on dev tooling and things like that. But he's also one of the guys who created DevOps Days. He wrote the DevOps Handbook. He's basically one of the people who in fact, he coined the name DevOps and was a massive part of this movement. He's working at Tessl, yay. And he used to work at Snyk with us as well for a couple of years. And he wrote this, he went to, recently went to the AI Engineers Summit in San Francisco and wrote a blog about that. This is an interesting one, though, the rise of parallel coding agents, whereby essentially what you do is you kick off a ton of coding agents and you just let them go based on whether it's specifications, based on whether it's prompts and requirements. They go off and do some stuff, and then they come back at the end. And you look at what they've each done, you can merge them, and there are tools that perform these workflows. Super, super interesting blog. Do take the time to read it. But there are a bunch of tools as well here. Async Code Agent, Crystal, CC Manager, Splitmind, Claude Squad, and Claude Code Crew. These are tools that actually do all the workflows for you to actually perform a lot of that parallelism, and then also looking at how they come back together at the end. So there's a ton of stuff like this that's also coming in the future that allows us not just to run this in a single path, but to kick it off in a more parallel way and then identify which is done best. Maybe I can merge certain things from one, certain things from the other. There's a big future out here for effectively having a team of agents and us being the manager of that team to achieve what we need. Cool. Oh, shit, I've got a few more slides, yeah. Yay, I've got some more slides. Okay, benefits of AI native development. This cycle is really, really important now. We make a functional change to the specification. The specification generates some code, but the key is that there is validation step, this validation cycle. We have to make sure that the code is a valid representation of our specification. We might implement in Node, but why stop there? Why would anyone want to stop at Node? We don't stop at Node. We go to better implementations like Java and other things like that. Based on context, this is adaptable software now. I might provide some context saying the spec's fine, but here's some context to build this application on my existing stack, which is a wonderful Java stack. Context changes based on maintenance. There could be a whole number of things that I need to update on my application. Shouldn't change the spec, it should change the context. Other business style things that we might want to input, whether it's policies, budget constraints, the business needs, this all comes in as context. It doesn't change the specification, it changes the way we build the target. And hopefully, as agents, models get better and better and better at writing this code, and we, most importantly, get better with this validation step so that we write the tests at every stage and every code changes goes through all those tests. We should be able to say, generate it, make it faster, improve security, whatever our context requires, feed it back, validate it back to the specification, and then spit out some generated node image. Of course, we don't stop there as well. Once we get to system telemetry, once we go into production, how is this actually acting in production? Let me take those signals, take those flags, send it back as context, and regenerate. My spec doesn't change because this is specific to that implementation. This is specific to the environment it's going in. This could be used by hundreds of different people that have different context requirements to the same specification. Of course, this makes software development much, much more inclusive because I, as a developer today, not all of my skills are going to be as useful in this new world because actually my coding skills become less interesting. But my knowledge of being a developer for 20-something years now has built me this knowledge of this wisdom of knowing how to deploy, knowing what good architecture looks like, knowing what good design is, knowing how to deploy something to scale. And all of this means if we want to build a real enterprise production style environment, yes, anyone can build. Anyone can do this. We sim vibe coding. Anyone can just type a few things in, but we need that experience, that ingrained experience that we have learned over years to say, this is what good architecture looks like. We need a good PM body to say, these are the things that the user needs. Okay, we'll have a ton of different people who can do this, but together with that knowledge, that wisdom, that experience, we'll be able to build this application more. But it will be a more inclusive space. There are a ton of questions that we don't know the answer to, but at Tessl, we're trying to look through, answer through the community. And the most important thing is AI native is a new development paradigm. We can't think about it in the same way as we're thinking about code-generated, code-centric. For example, how do you version adaptable implementations? If you have a version of a spec, and then you have a number of implementations, all that have different revisions through context changes, how do you make sure that that version of the code, that version of the implementation references the version of the spec it came from, but triggers up every single time? There are a ton of questions here. Because we're in a new paradigm, we need to think about much more deeply. And an interesting one at the bottom there, on the right, what is the role of an AI native developer? We've got some ideas. Developers will absolutely still be around. This isn't an AI world that is just, YOLO go. It is for a disposable application. If I wanted an interrupt every 5 seconds, I'll either call you or I'll write this application. But I'm not putting that into production. Right? There's a ton of reasons why I wouldn't put that into production, as Matt talked through, right? But it's, as a disposable app, it's amazing. Is that me? Oh no, a couple more. I promise, a couple more. At Tessl, yeah, this is what we're working on. The Specify, that's just it's not even open source. It's just literally a YOLO style. What can we do with this? But at Tessl, we are building something, a framework, a platform that will allow you to do all these types of things. And we're not doing it by ourselves. We believe this is an open space where every single AI vendor, every single person who's trying to build AI tooling should be able to integrate, should be able to connect and provide their value in as a step, as a component in this workflow to be able to say, oh, you want to do documentation with Swim? You want to do testing with Codo? That's fine. Let's add these as parts of our workflow. But we need this workflow to be end to end. And this is one of the things that we're building. The AI native landscape, as mentioned, can I click on that? I can. AI native landscape, as mentioned, is an amazing resource where you can actually look through a whole ton of various AI native and AI dev tools. Feel free to go there. It's an open source repo, so feel free to send pull requests. There's some Google Forms there if you wanted to add in tools that you use or have built as well. We'll definitely accept those. And I think, oh my gosh, where's it gone? I think, well, it absolutely is the end of the presentation because I can't get this back. So there we go. I'm pretty sure the next one's thank you. Thank you. I went a touch over. If anyone needs to go, if anyone wants to grab a beer, please do. But any questions? Sir?
I have one question. So it seems like
I think this is the right sort of way to do this. The one part where I'm not, this question is, for instance, you have a setup and you want a change, right? Would you need to kind of say, okay, I need to go change the spec and then the tests and then drive the development? Or would you want to do it the other way, i.e., go update the code, which is already based on a set of tests that should run, and then you check what you have, and if that's correct, then go back and update the spec. Because it seems a bit, again, wasteful, if I may, in a vibe coding kind of world where actually I may not even want to accept 15 of these changes and only get to a point where this is what I want to do.
Yeah, really great question. So the question was, so first of all, a comment just to say you think it's the right path. You said the session was amazing. You said if a change needed to be made, would it be better to go and change the code itself and either then make a change back to the spec, or if I may, have a system recognize the change in the test in the code to actually suggest a change to make to the specification?
Yeah, I'm saying I do believe that the spec should change. Actually,
Yeah.
I do agree with that. I think this is the right way to do this. I'm just questioning: is it spec change first and code, or is it code change?
Yeah.
And
No,
when it's okay, you go back and then update the spec.
And the question and the addition I was making is, if you only change the code, you could actually have the system recognize what you're changing and suggest a change to the spec. So it's another,
Correct.
yeah. I think it's completely valid. Number one. Number two is, I think if you make the change to the code, it requires someone who is very understanding of the code, number one. I think that's easy if you have existing developer teams right now that own specific components and so forth. I believe as we evolve more into the spec world, that won't happen as much. We will actually detach ourselves from the code. Today, though, where we are still very code savvy, where people sometimes will find it faster actually as well to make a code change, I think that's reasonable. But I think it's only reasonable if, when you make that change back to the spec, it generates the code that is in a similar way. Because if I make a change to my specification and it makes a completely different change, then I might have to then go ahead, because it might think, oh, actually, I might refactor some certain things, because there may actually be a more performant way of doing things, and et cetera, et cetera. So it's a perfectly valid way of doing it. It's just a choice. And today, people who are more comfortable going into the code would make that choice. But yeah, I think both are valid. So long as we don't drop into that place where we're making code changes without making an update to the spec, because then the code immediately becomes the source of truth.
Yeah, I mean, I think the backstop is a test.
Yeah, 100%, 100%. Yeah. Yep, agree. Anyone else have thoughts on that? Agree with that? Yeah, sorry, why don't you go first?
About the tool, the Spec-driven tool.
You were waiting for me to crack that then, weren't you? I saw.
I tried to make it available to people because it looks.
The Spec-driven tool, yeah, it was super interesting. It was just 2 weeks old. Sorry, no, not 2 weeks old. It took 2 weeks to build. It was vibe coded. There are probably a million things that are wrong with it. And we're actually building a far more expensive version of that tool, which if you follow Tessl.io, you'll absolutely get early access to. But this is the style, this is the type of thing that we are that we're looking at building in this kind of way. We wanted to build it in a much more production ready way, with a whole ton of other things, which we're going through private beta now. So if you're interested, ping me an email, simon@tessl.io, and I'll help you get onto that early access program, and you can give us feedback. We're hoping not long now, we can hopefully be open beta. But yeah, absolutely, that was just a YOLO kind of vibe coding thing. You don't want to go fully production with that. You want something more well built. No problem. At the back, yeah.
You spoke about, I think an important bit you touched on was that the skill of the developer won't go away. Now, you mentioned that the spec itself, through giving a lot of examples through requirements. So I, as a user, want to do this when I do this could that then transform to actually an architectural record
Mhm.
of I want components that are cohesive, and I want things in my code to be like decoupled in this way,
Mhm.
and then this, so that is the spec flow of how the system is designed,
Yeah.
with context and reference to changing requirements as well.
Yeah, really great question. So I'm not sure I'm going to be able to repeat that whole thing, but it was all really about how the architecture of that application is defined, whether it's in the spec or maybe even a side spec or something that defines an application. And I think yeah, absolutely. The ability for us to break down components in a certain way where we know it's the right way of doing it through our design. AI can have a good crack at that. Sometimes it'll be right, sometimes it will be wrong, but it does need context, because actually I would architect, if I have different business needs and different deployment needs, I'd architect my application in a different way. And I'd actually compose my components in such a way whereby that would be possible for people to do that fairly easily. So today, we know how to architect, how to construct and design applications that it's reusable, so that things are services and things work well together. At Tessl, we're looking at, if you ask something, we break this down into a number of different steps and components and stages. Now that might be right, it might be wrong. It's important to be able to then give feedback into that, to say, I want this to look more like this. I want the APIs between these components to work like this. And you're doing that because you actually have the wisdom, and I think it's important to use that word, the wisdom through experience, to know what good design and what good architecture looks like. And that's the bit that we as developers will provide into this new process, the understanding of how good applications are built. The other piece, the capabilities, for example, this is what good PMs are good at. This is what good people who can describe a good requirements part says, these are the things I care about. And actually the bottleneck almost sits there, because as we're able to deliver fast, how much do we deliver? How much user feedback do we get? How do we iterate on this application? A good PM will be very clearly distinct from a bad PM there, who delivers too much of a bad thing without enough feedback and things like that. But yeah, there's a number of roles like that. Did that answer your question? It did. There's a number of roles like that that are important, so that if you have a good PM style persona, a good developer architect persona, and developers will need to level up into that architect design space, and other people who know what good intent and what good, not necessarily defining exactly what performance looks like and things like that, because the LLMs can learn those types of things, but recognizing the non-functional parts and building that in is super important. I think you had next.
Something I wasn't completely sure on.
Yeah.
Clarity is, in that model, when you're changing the spec, how disposable is the code? Is it all regenerated every time?
Yeah,
or
great question.
Can it be incremental? So is it effectively immutable code that you throw away and regenerate?
Great question. So the question was, every time you iterate on the specification, how disposable is the existing code from the previous version of the spec to the new? Does it rewrite the whole thing, or does it just update? So I think one important thing is, and one of the things that we're kind of like going through the process of learning as well, is it's important to document, I think, the ways in which when we create an implementation, when we generate, what decisions are made. Because whether it's a decision that we made or a decision that an LLM made, we might say, actually, that's a really interesting decision. I want to promote that up to my main specification. Or maybe it should be part of, I don't know, I'm going to say the word shadow spec here, which maybe sits underneath the specification that captures a bunch of decisions that the LLM made. There's more implementation decisions. What we don't want is a complete regeneration every single time, because actually then we're just going to keep spinning the dice, keep rolling the dice until, finally all my tests are passed now. When actually what I really want is understand which parts of my code base needs to change, make those changes only, and actually, breaking everything down into super modular spaces helps this significantly. And if you do need to regenerate, amounts of this, regenerate it with this shadow spec in mind, so that it uses past decisions that the user didn't make, but the previous LLMs did, so that we don't actually see changes in behavior, so that that button doesn't change from blue to black, such that the way implementations are built doesn't mean that, oh, these unit tests are now rubbish, I have to respin and create new unit tests for this method. We want to limit that as much as possible by learning from what we built the previous time. So yeah, I think however it's done, whether it's a shadow spec that captures information, whether we use code as context in our change, whether we try and break it down so that everything's so small you actually only regenerate parts of the code. There are a number of ways it could be done, but I think what you're the problem you're stating is very much top of mind for people who are doing this regeneration. Yeah.
So there isn't one answer.
I don't think there's one answer, and I don't think there's one correct way, but I think it's definitely a thing that we can't leave to this non-determinism whereby it just changes every time. Like the idea of composing your application into a ton of components, whereby actually they're so small, you actually just only need to change. You need to identify which components you need to change and just respin those.
So a lot
Yeah, exactly. Yeah. And again, a lot of that is through architecture choices and things like that. Yeah.
Thanks for the first thing. And I'm going to reformulate the same question I asked at the end of the previous talk. Like, in this scenario in which at the end you're going to talk with the LLM, there is the problem with the context window again.
Yeah.
Like, what's your idea about what is the unit for a spec? Like, with a growing project? Like, is it going to be one for everything? How do you... I'm gonna split it. No, don't answer the pen.
No. I'll use the same answer. Whatever the answer was, I'll use the same answer. No. I hear you. Yeah.
Another small question next to it is like, does it make sense to add to the specs some really specific personas, like define the tasks, like developer, DevOps, things like this?
Yeah.
Specific. Well.
Yeah. Great question. So first question, it absolutely makes sense to break everything down. The way we see it is, if you were to provide me with a brief that has a much greater task, I might say, well, actually, I'm going to create a top level spec, and then for every component that I have underneath, I'm effectively creating a tree of components. Every component then has its own specification, its own API, and its own set of tests. Then, if I want to make a change, I make a change just to the specification that I'm calling. Each of the parent components that use that smaller component, they're now the integration tests for that. And the tests that exist in there are kind of like a little bit more unit test style for this component. And this is super important because as we ship, we don't want to ship it as one. We want to ship it as every single unit that is actually reusable if you wanted to maybe create another app. And actually, you don't need to rebuild all these extra things. You might say, that component there, I want to use it as is. And this one, and this one, and this one, because half of what we build, as developers, we write glue code. That's what we do, right? Half of what we do is out there already in open source and other things. We're building on that so much. We just need to effectively write these few things, and then 80% of our code base is borrowed or used. So that's if we're not doing that, then we're breaking some of our biggest gains in the last 20 years of software development. Your second question was?
Like having more vertical personas.
Oh, personas. Yeah, I think that's really interesting. And I think from this point of view, I don't think it matters whether you're spec-centric or code-centric. I think, it's exactly that similar case whereby, maybe you have different agents looking and they have a different background and that different way of looking at the code. Maybe you have a tester persona that's looking at building out those test cases. I think at that point, we're using all the best practices that we learned from using LLMs. I don't think it makes sense. And I'd even go further. I'd even say, don't just stop at personas, have different models. Use different models for generating code, different models for creating specs, different models for generating your tests. Each of these models are good at different things, or even different flavors of the same model or group of models from a certain provider. We change everything based on what is best for this task. Were you next? Yeah, I think you were next. Yeah.
So I mean, some of this was already touched on, but basically we need like this hierarchy of specs, right? And
Yeah.
then maybe on the top is like the company mission statement.
Just says do it. Yeah.
And
Yeah.
just deliver on that.
Yeah.
10% growth year on year, and then you kind of go down, and like in a big company there would be all these kind of like departments and product groups and products and and then I guess that's the trick.
Yeah, I wouldn't necessarily say it's a tree that big. I would say it's kind of nice to continue to be fairly shallow in terms of what we're building. I think it gets too unmanageable. The more depth and the greater this whole thing is. I think we as developers will actually start broadening ourselves massively and understanding huge parts of the application that we wouldn't normally look at. But I still see these as actually much smaller units. Applications, I think, will probably, I mean, I don't know if they will change size massively, but I think keeping them similar size, I don't see necessarily the need to change that. I think it is good to, though, share decisions that are made as business decisions or things that should be reused. Like I love the comment, I think it was, about prompts being shared. Like a ton of people do that. Like Cody have this prompt library where you can actually store prompts, and I think AI engineering teams, I mentioned this to someone in the hall, AI engineering teams are able to say, this is the prompt library, and my teams can use various prompts, a good prompt that makes me create tests in a good way. Exactly the same, like there should be things we share, but applications can still be, I don't want to say pizza box or pizza order, whatever the phrase is, 2 pizza teams, that kind of, size.
I mean, I guess the worry is then with an LLM, you might get like much more optimized local maximums. So like one team would kind of hyper optimize for their case to the detriment of the rest of the business.
That's how we design and we architect the application, right? We can't just let the LLM do whatever it wants. We need to be in control of the LLM. We can't be the LLM's agent. The agents need to work for us. So if the agent's doing something that we disagree with from an architecture point of view, a maintenance point of view, a company team point of view, we change it and we tell it, no, this is wrong. Whether it's just the architecture of the app or the way it's trying to build multiple applications, yeah, that's on us. That's us accept alling then. Yeah. Cool. One last question, or maybe we do one in the hall. Oh no, it's Farhat. He's going to ask a really hard question. Thank you everyone for. No, go on, Farhat. Go on.
I've been seeing stuff about like UIs and software that adapts to the user.
Yeah.
How would like a static spec? How would that fit into a world where the software changes to the user? So yeah, the way the user changes it, or they ask for it to appear in a certain way. How would static spec, if that's what you're going for, maybe you're not going for that.
Well, I don't think it needs to be a static spec. If we try and compare a spec-centric versus a code-centric, in exactly the same way, would you consider the code to be static?
Well, I mean, there's like multiple users, right?
Yep.
So you'd have a different spec for each person. Would you store them? Like have you thought about this before?
No, it's not. It's definitely not a use case I've thought about. It's a good question though. Really good question. Yeah, I haven't even thought. What would you think?
I guess the point is about modularity and small pieces kind of makes some sort of sense. Maybe, yeah, having that sort of, depending on how the user's using the software, implementing certain parts of it, but then changing other parts, and some sort of memory, like OpenAI, the ChatGPT has some sort of memory.
Yeah.
And some sort of memory there that this person likes to use their software in this sort of way. That simple interface, way a power user like more complex stuff.
Yeah.
And that could maybe apply to the whole operating.
I love the OSGI model. If we take you back about 20 years, the OSGI model of being able to, whatever pieces of software you drop in at the time, it reacts to it live and kind of like spawns things up and does things like that. These are kind of like using some of those old techniques to kind of like spawn things up and change the way things look just by dropping things in based on user needs and things like that. We can probably learn from things like that as well. But yeah, definitely not a use case I've thought about. Anyone else thought about that kind of use case? See, you're a trailblazer.
We were going to write a piece about this, like the new age of interfaces and what they would look like. So
there we go. AI native dev.io/blog. Bab's going to answer that question in a blog.
No, we need you to write that piece for us.
Yeah, there we go. Farhad, we've sorted it. We're going to write that post for us, Bab, and then it's going to be there. Cool. Thank you so much. Really appreciate it. Let's grab some more beers and chat in the corridor.